we studied that the entity classes of any system have logical link with one another. This logical relationship is the theme of this unit. Introduction. This unit describes the basic architecture of entity relationship model. It also focuses on modeling of various types of entity classes and the development of complete entity relationship model. Objectives. The objectives of the unit are to understand architecture of entity relationship model, various types of relationships, how the complexities of relationship are handled, the effect of cardinality in relationships, how multi-valued attributes are modeled, how time-dependent attributes are modeled, how associative entity types are modeled. Degree of relationship. The degree of a relationship is the total number of entity classes that participate in that relationship. Dear learners, look at these examples. Example number 1. The relationship manage has only one entity class, that is employee. Therefore, the degree of relationship manage is 1. Example number 2. The relationship place has two entity classes that are customer and order. Therefore, the degree of relationship place is 2. Example number 3. The relationship takes has three entity classes that are student, faculty and course. Therefore, the degree of relationship takes is 3. Dear learners, the degree of a relationship is not restricted to 3, but the degree of a relationship beyond ternary is considered being a poor practice as it increases complexity. Therefore, the higher degree relationship are advised to decompose in order to make it simple. Let us now discuss how the higher degree relationship create complexity by taking this example as shown. Look at the ER model. The degree of relationship takes is 4 as there are 4 entity classes involved. These are number 1 student, number 2 faculty, number 3 project, number 4 course. The complexity can be easily judged by reading the model as many students registered many courses, many students registered for many projects. Many faculty members are assigned many courses. Many faculty members supervise many projects. The single relationship is sometimes difficult to name. Moreover, the relationship takes shows a direct relationship between entity classes, project and courses, which does not exist actually. The relationship takes may be decomposed as shown. Look at the modified version of degree 4 relationship takes. The relationship register connects entity class student with entity class course as many students register many courses. The relationship takes connects 3 entity classes student, project and faculty as many students register many projects and projects are taken by many faculty members. The relationship assignment connects entity class course with entity class faculty as many courses are assigned to many faculty members. Modeling multi-valued attributes. Dear learners, let us consider instances of a multi-valued attribute phone before its modeling. As shown as, the analysis shows these drawbacks. Number 1. The attribute registration number is supposed to be a primary key, but due to existence of multi-valued attribute phone, it could not be defined. Number 2. There is redundancy due to existence of multi-valued attribute phone, that is name Daniel is placed 3 times because having 3 phone numbers. Thus, adding value of phone number creates redundancy, which is considered one of the major drawbacks. These problems can be resolved by adopting this general procedure. The multi-valued attribute is converted into new entity class. The newly created entity class have the composite key with primary key attribute of original entity class. Establish relationship between original entity class and newly created entity class. Dear learners, there are 2 possibilities for existence of multi-valued attributes. Each one is dealt in a different way. These are single multi-valued attribute. If there is only one multi-valued attribute in an entity class, then it is converted into separate new entity class. The class name and attributes are required to be defined. For example, consider the entity class student with two single-valued attributes, registration number and name, and one multi-valued attribute, phone, as shown. The multi-valued attribute phone number is converted into new entity class phone, as shown. The newly created entity class phone has two attributes, registration number and phone number. Both attributes collectively form composite key. The relationship have is established between original entity class student and newly created entity class phone. Dear learners, this modeling of multi-valued attribute introduces new types of entity classes. These are associative entity class. The entity class with composite key or have existence dependency is called associative entity. The associative entity class is also called weak entity class. It is represented by a rectangle with lines. Regularly discuss the basic principles of super and subtypes modeling. But in developing real-world data models, how can we recognize the opportunities to explore the super and subtype relationship? There are two processes which serve as mental model in developing super and subtypes relationships. These are generalization, specialization. Let us discuss each one in detail. Generalization. In data modeling, the generalization is the process of defining a more general entity from a set of more specialized entity types. For example, consider these three entity types as shown. The entity car has attributes vehicle identification number, color, price, and engine capacity. The entity motorcycle has attributes vehicle identification number and price. The entity truck has attributes vehicle identification number, price, and maximum load. It becomes clear by closely examining these entities that the attributes vehicle identification number and price are common. This fact reiterates that each of the given entity types is a version of more general entity type vehicle as shown. The subtype car has attributes color and engine capacity. It inherits all attributes of its supertype vehicle as it is an instance of it. Similarly, the subtype truck has attribute maximum load. It also inherits all attributes of its supertype vehicle as it is an instance of it. Dear learners, the entity type motorcycle is missing here. Is this simply an omission? No, it is deliberately not included because it does not satisfy the condition for a subtype, that is, the motorcycle entity type does not have unique attribute, which is necessarily be present for existence as subtype of a supertype. The absence of motorcycle entity type also shows that an instance of a supertype is not necessarily be a member of any of the defined subtypes. This is discussed further in the next section. Let us now discuss the second process of mental model in developing super and subtypes relationships, that is, specialization. In data modeling, the specialization is the process of defining one or more subtypes of the supertype and forming super and subtype relationship. For example, consider the entity type vehicle. The attributes are vehicle identification number as primary key, price, color, engine, capacity, and maximum load. After further discussion with user of these vehicles, it is discovered that two types of vehicles are used. Each has unique attributes. The domain of stated problem clearly demonstrates that the most general entity type vehicle shall be decomposed into more specialized subtypes, each with unique attributes as shown. Dear learners, now it is clear that generalization and specialization are two techniques used for modeling of super and subtypes. These are summarized as: the generalization technique is bottom-up approach while the specialization technique is top-down approach. The application of either of these techniques depends upon nature of problem domain, previous modeling efforts, if any, and maybe personal preferences. Dear learners, notations. Let us now discuss the symbols which are used to develop the ER model. These are rectangle. The entity class is represented by a rectangle. The name of entity class is written inside, as shown. For example, the entity class student is represented as shown. Oval. The attributes are represented as an oval-shaped symbol. The name of attribute is written inside, as shown. For example, the attribute name is represented as shown. Dear learners, let us discuss the representation of different types of attribute. These are multi-valued attribute. The multi-valued attribute is represented by double oval shaped symbol. The name of attribute is written inside, as shown. For example, the multi-valued attribute courses are represented as shown. Derived attribute. The derived attribute is represented by dashed oval shaped symbol. The name of attribute is written inside, as shown. For example, the derived attribute age is represented as shown. Primary key attribute. The primary key attribute is represented as an oval shaped symbol. The name of attribute is underlined and written inside, as shown. For example, the attribute registration number is represented as shown. Composite key attribute. Each attribute of composite key is represented by an oval shaped symbol with underlying the attribute name written inside, as shown. For example, the attributes roll number and shift are shown as symbol of ER model is straight lines. Recall, we learned previously that attributes are the defined properties of an entity class. This means that attributes are always associated with an entity class. The straight lines are used to connect attributes to an entity class, as shown as, for example, the entity class student has three attributes: registration number, name, and address. These are connected by straight lines, as shown. Diamond. Recall once again, we learned previously that entity classes are logically connected or related with one another. This relationship is very important in the database design and implementation. It is the glue that holds together various entity classes of an ER model. The relationship in ER model is represented as diamond-shaped symbol. The name of relationship is written inside, as shown. For example, the relationship named register is represented as shown.